Good morning again, guys.
Good morning, sir.
Good morning.
Good. So, like I was saying earlier on, today we said our lesson uh, is linear transformations in elective mathematics. So, we look at the overview of our today's lesson. And going through the overview, we've discussed linear transformations 1 and 2. Is there any problem? Is any of you having any problem? Is any of you having any challenge there before we move on with the linear transformation part 3? So if there is no problem, we said in this lesson, we shall be looking at the composition of linear transformations, the identity transformations, and their matrices. Again, looking at the objectives in this lesson, we believe that at the end of this lesson, you will be able to find the composition of linear transformations. You will also be able to recognize the identity transformations, and you will be able to find the equation of the image of a line under a linear transformation. We begin with composition of linear transformations. What is a linear transformation? Or what is the meaning of the composition of a linear transformation? Now, the combination of two matrices P and Q. So we assume the P and the Q here are two matrices of a linear transformation, POQ. Now, POQ here means Q followed by P is given by the product PQ, which means that if you're finding the composition of two matrices, is simply the product of the matrices. The first matrix followed by the second matrix. So we have POQ equal to PQ. Also, S followed by T is given by TOS. This is equal to TS. That is the product of the matrix T and S. That is the meaning of the composition of a linear transformation. Caleb, any question?
Sir, no.
Good. Now, finding the composition of a linear transformation. We want to see how we can find the composition of two or more transformations when you are giving them. The steps involved are now, given the two linear transformations, P and Q, so we are assuming that the two transformations there, P and Q, are linear. The first thing you need to do is to write down the matrices for P and Q. So you are going to have the matrix P and the matrix Q. The next thing is to find the product of the matrix P and Q, and that gives you PQ. These are the steps you need to go through when you want to find the composition of a linear transformation. We pick some illustrative examples. If R equal the matrix 7, 9, 1, 6, T equal negative 3, 1, 0, 4, and S equal 9, negative 2, and 5, 0. Find A, the combined transformation SOT. B, the combined transformation of T followed by R. And C, the image of 2, 3 under the transformation S followed by R. This is the problem. Let's see how we are going to apply the steps described above to solve this problem. Caleb, have you finished copying?
Yes, sir.
Kumi Monica, have you finished?
Yes, sir.
Good. Now, our solution. SOT is the same as ST. That is T followed by S. ST is the same as T followed by S. And that is equal to the matrix S multiplying the matrix T. The matrix S, we have 9, negative 2, 5, 0. And the matrix T, we have negative 3, 1, 0, 4. We know matrix multiplications already. For the sake of those who were not here, this is what we do. The 9 in the first row, first column, will multiply negative 3 in the first row, first column of the second matrix. So 9 times negative 3 gives us negative 27. Plus negative 2 in the first row, second column, will multiply the 0 in the first row, first column in the second matrix. And that gives us negative 2 times 0, we have 0. The same way you do, 9 multiply 1 gives us 1. Negative 2 multiplies the 4 will give us negative 8, and that gives us 9 minus 8. You do the same to the second row. 5 multiplying negative 3 gives us negative 15. Then 0 multiplies 0 also give us plus 0. So we pick the 5 again, multiply the 1 in the first row, second column. That gives you 5 plus the 0 multiplying the 4 in the second row, second column. That gives us 0. If you perform the operation, then we have negative 27 plus 0, negative 27. 9 minus 8, we have 1. Negative 15 plus 0 will give us negative 15. 5 plus 0, we have 5. This is the solution to the first problem. ST, that is the matrix S multiplying the matrix T, or the matrix T followed by the matrix S. The second one, we have to find the transformation T followed by R, that is RT. So if you do this multiplication, that is the matrix R multiplying the matrix T, it will lead us to an answer. What is the answer there? If you solve this, what will be your answer? Kuma Jasper, Amuzo Matthew, Amuzo Matthew, can you hear me? Nana Kofi, okay.
So
Okay, Nana Kofi, we can't hear you clearly, but yes, Mensa Theophilus.
I have my answer to be
Say, I had I had RT to be negative 21, 43, negative 3, and 25.
Okay. Haibo Maxwell, what's your answer? Daniel Ewoy, what's your answer?
I had negative 21, 43, negative 3, and 25.
Okay. So let's compare our answers now. So if you expand this, we have the next step. Negative 21 plus 0, 7 plus 36, negative 3 plus 0, 1 plus 24. So we have negative 21, 43, negative 3, 25. That is your answer. The next one, we are finding the image of S followed by R. S followed by R. So first, we need to find the transformation S followed by R. Then we can now find the image of 2, 3 under the resulting matrix. So we solve for RS. Solving for our RS, we have 63 plus 45, negative 14, 0, plus 0, 9 plus 30, and negative 2 plus 0. If you simplify, we have 108, negative 14, 39, negative 2. Did you all get the same answer? Ajima, Lawe.
Yes, sir.
Okay. Amema Courage. We can now find the image. Hence, the image of 2, 3 under the transformation S followed by R will be equal to, so we have the transformation S. Then we multiply that by the given point. The given point is 2, 3. So this is going to give us 108 times 2, we have 216, plus negative 14 times 3 will also give us negative 42. So we have 216 minus 42. 39 times 2 will also give us 78, plus negative 2 times 3 will also give us negative 6, and that gives you 78 minus the 6. So your final answer will be 174 and 72. That is the image of 2, 3 under the linear transformation R followed by S. Caleb, do you understand that?
Yes, sir.
Kuma Jasper, are you following? Okay. Identity transformations and their matrices. Identity transformations and their matrices. Now, we have the type of transformation, the image formed, and the matrix. The type of transformation, the image formed, and the matrix. The matrices, instead of CE, you can do it X. So TIX, TIX. Theophilus, did you see that? Did you see the correction?
Yes.
Good. Now, the first one, we have reflection. So reflection is the first type of transformation we shall be talking about here. And that reflection, we have several forms of reflection. The first one is reflection in the x-axis. Now, reflection in the x-axis is the same as the reflection in the line y equal to 0. So, if you have the Cartesian plane, now let's go to the board. If you have a Cartesian plane, so let's assume this is vertical, this is the horizontal. we have both the x and then the y axis. Now, reflection in the x-axis, we said that is the same as the reflection in the line y equal to 0. We know that this is the point of origin, which is always 0. If that is 0, then we can say that reflection in the line y equal to 0 is going to be reflection in the line y equal to 0 is going to lie on the horizontal axis. Let's assume this is straight. Now, if this is my y equal to 0, this is what is going to happen. We need to find the image, which means that if you have an object, you have an object, let's say a square in the first quadrant, and you want to reflect this in the x-axis, your y equal to 0 becomes the mirror line. Your y equal to 0, that's the red line there, is the mirror line. So let me label the regions here. I want to label the regions. So I have region 1, I have region 2, I have region 3, and then I have region 4. Now, if you want to reflect this object in the line y equal to 0 or in the x-axis, which region will the image be formed? Caleb, which of the regions there will the image be formed? Let me explain this again. The red line is the mirror. So if you have a mirror and you place a mirror on the table and you are sitting in front of the mirror, so you are here facing the mirror, where will you find your image? Kuma Jasper. Daniel Ewoy.
Say region 4.
Region 4. Region 4. Now, so to write your image, we write the value on the horizontal axis first before the value on the vertical axis. So to get the image, what is going to be the image? Your XY, the mapping, that is X, Y, maps to the image. What will be the image? Haibo Maxwell. So your image will be in region 4. Let's draw it here. This is the square. So let's write the image. If the value on the horizontal axis is going to be what? Ajima Lawe.
So it's going to be
Okay, in terms of
x.
X and Y, in terms of X
Mhm.
and Y, what will be the
Yes.
value and the sign? Okay, the value
Okay.
and
Okay.
the sign.
Okay. So the x will be normal x, and then the y will be minus y, because it's at the bottom, and the bottom is minus y.
Okay, all right. Amuzu Matthew. So you are saying that your image will be the X, comma, and then negative Y. That gives you the image here. Dogbe Roslyn, do you understand that?
Yes, sir.
Good. So let's go back to the lesson there. So we can now say confidently that your image formed will be x negative y. Xy maps to x negative y. Now, in the matrix, you will now have, now writing the transformation or writing the matrix, you will see that the x here, if you come to the left side, we have x and the y here is 0. So we have 1, 0. And then when you come here, there is no x. That also gives you 0, negative 1. That gives you the matrix of the transformation, reflection in the x-axis. So the same way, we can also find for the reflection in the line what x equal to 0, or reflection in the x-axis. And reflection in the x-axis, your xy will now map to negative xy. Let's see how we got the negative xy. Let's go to the blackboard again. Let's write there so that we can all identify it in our graphs. So again, we have the diagram here. So we have, let me draw it. Um, the x and the y axis. Okay. Now, we have an object in region 1, reflection in the y axis. This is reflection in the line x equal to 0. So reflection in the line x equal to 0 will also give us this. Let's draw that. X equal to 0 will give us this. So this red line becomes the mirror line. If this is the mirror line, then if you are in front of the mirror, you are here, you are the object. After bathing, you are sitting in front of the mirror. This is the back of the mirror. So now, to find your image, we know that your image is going to reflect here. You find it at the back of the mirror here. And to write the image transformation, that is going to give you. Now, the value on the horizontal axis is always negative. From the center to the left is negative. So that is going to give you the negative x. Then we take the value on the vertical axis, and that also gives you positive y. So reflection in the line x equal to 0 or in the y axis gives you the image negative xy. So if you go back there, that leads us to the information we have here. So the matrix there is going to be -1, 0, since only x is here, and then 0, 1. That is the matrix. Now, if you go to reflection in the line y equal to x, let me just explain this here, then we go. Later, you can try with sketching it. This is the same as, meaning if you put in y, you get x. If you put in x, you get y. So xy maps to yx. What does that mean? If you have y equal to x, let's look for the value on the horizontal axis. That means we should solve for x. If you solve for x this equation, in this equation, then we are getting x equal to y. So in place of x, you put y. So we have, this is our x. So the image is now going to give you the y. Again, if you are making y the subject, your y equal to x, which means that in the y-axis, go and put x there. So your y will also lead us to the image x. And that gives you the matrix 0, 1, 1, 0. Reflection in the y-axis also follows the same pattern. That is the identity transformations and their matrices. So the first one, we've discussed reflection. Any problem here, please? Amuzu Matthew, any problem here?
No, sir.
Good. I hope you can do the rest.
Yes, sir.
Okay. Now, we go to the next type of transformation in this lesson. The next type, we have enlargement. We enlarge a figure with a scale factor. So if you enlarge with a scale factor, we have xy maps to the scale factor, which is xy, and that will give you kx, ky. So the scale, the k, could be any number, negative or positive. Now, if you multiply that by your x, it gives you kx. If you multiply that by y, you get ky. So the matrix k0 and then 0k. K0 because the coefficient of x is k and the coefficient of y is also k. We go to rotation. Very interesting aspect of the transformation. Now, rotation through an angle of 90 degrees. You know, we can rotate. If you are sitting in a chair, you can, you know, turn yourself left and right, uh, back and forth in that order. And we can rotate through a certain angle. So the first one, rotation through an angle of 90 degrees. One thing you must know is this. Whenever the direction of rotation is not given, then we assume it is through anti-clockwise direction. Let's see how we can get the image for a rotation through an angle of 90 degrees. To do that, let's go back to the board and get it sketched. Now, if I have this, the Cartesian plane, as usual, we will always get the Cartesian plane. We want to rotate your door. You can rotate the door. You know, the door has a fixed point. That's the hinge. So you can rotate your door. Like I said earlier on, you can uh, uh, pick anything and rotate it, turn it around. So my Cartesian plane, let me insert the lines. So we have the X, and then we also have the Y axis. If I have an object and we are rotating anti-clockwise through 90 degrees above the origin, we said that this is the origin, 0, 0, the coordinates is always 0, 0. Anti-clockwise, which means that if I should turn this, if I should turn it this way, my image is going to be formed here. Let's see how the rotation was done. Now, before you can turn, this leg must move, the Y must move, and the X will occupy that position. So I'm going to move the Y and the X. Now, in place of Y here, I'll put X. Remember, your Y moved first to take this position. That is why rotation, you are only turning to the left once, 90 degrees. If you turn twice, that will give you 180 degrees, 270 degrees. So the image is also going to give us negative y, x, negative y, x. Since values to the left of the vertical line or the left of the origin will be negative on the horizontal axis. And then above the origin will also be positive. So we have negative y, x. That will be the image. So that we can now form the image negative y, x. We can do the same thing, rotation through an angle of 180 degrees. You are turning 2 times. So you will be in the third region, and that also gives you negative x, negative y. So we have the matrix formed, and rotation through an angle of 270 degrees will also give us y negative x. That is about rotation. Caleb, do you have any problem?
Sir, can you please explain once more time again?
Which one is that?
Sir, the number 2.
180 degrees.
Yes, sir.
Let's go to the marker board. Now, we have the Cartesian plane. As usual, x and y. So, sorry. Now, we have an object in the first region here. I hope you can see that. My x is here. My y is also here. Now we want to rotate through 180 degrees anti-clockwise about the origin. So if you want to rotate through 180 degrees, we are going to move your x and y 2 times. So first, this is what we are going to do. Your y here is going to move. And if your y should move, we are getting your y here, which means that this y will now leave. Then we go for our x. Now, if you go for your x, this x will now live here and occupy the position of y. So your x will now be here. And we know that this will give us what? 90 degrees. We need 180 degrees, which means that we need to rotate the second time. To rotate the second time, this leg must move before the x also, or this leg takes that position. So my y is going to move. It will move and come to the other side of it. When it moves, it will now come here. Then my x is also going to move. If my x moves, then we now have this. My x will also come here. And we've now turned 180 degrees, another one. So the image is going to be formed here. Now, if you know the region where your image is formed, we can now read the coordinates of the image. Reading the value on the horizontal axis, that gives us x. And because it is at the left of the horizontal axis, we say negative x. Y is also below the horizontal axis. All values of y below the horizontal axis are negative. So this also gives us negative y. So the image will be negative x and then negative y. My brother, do you follow now?
Yes, sir.
Good. So you can do the same thing to the 270 degrees. Is that clear? You can try that.
Yes, sir.
You can try that.
Thank you, sir.
You are welcome, my brother. Now, we go to the next type of transformation. Identity transformation. So identity transformation, your image is always the same as the point. So we have 1, 0, 0, 1. The x here is the 1, and the y, when it comes to the row, we have y to be 0. So we have 1, 0. When you come to the second row, your x is also 0, your y is also 1. Rotation through an angle of theta is given as xy maps to x cos theta minus y sin theta. X sin theta, please, you can do this correction. This is x sin theta, it is sin theta plus y cos theta. So your matrix, we have cos theta, negative sin theta, cos theta. Then rotation or clockwise rotation through an angle of theta, we only replace the theta by negative theta. And that will also lead us to negative cos theta sin theta, because if you negate this, it gives you negative cos theta. If you negate this, it gives you sin theta. If you negate this, sin theta, it gives you negative sin theta. Then if you negate cos theta, it gives you negative cos theta. take note of these types of transformations. We shall be using them to solve some questions. Examples. We want to apply this to solve some questions. The first example, write down the linear transformations P and Q whose matrices are P equal 1, 2, 3, 4 and Q equal 5, 6, 7, 8. We are writing the linear transformations for the matrix P and the matrix Q. After that, we have to find PQ, that is Q followed by P. The image of a point XY under the transformation P plus Q. Find QOP where QOP means P followed by Q. That is the question. Let's all try this question and compare our answers. Everybody should try this question. If you are done with the first one, that is, if you are done writing the linear transformations for P and Q, you raise your hand and let's see your answer. Let's look at the suggested solution. So Px, the transformation P in terms of xy will give us the matrix P multiplying xy, and that gives us x plus 2y. That's 1 times x will give us x plus the 2 times y will also give us 2y. 3 times x will give us 3x, and then plus 4 times y will give us 4y. The Q, 5, 6, 7, 8 multiplying xy will also give us 5 times x, 5x plus the 6 times y, 6y. 7 times x will give us 7x plus the 8 times y, 8y. These are the linear transformations of the matrices P and Q. The linear transformations of P and Q. The next, we are finding PQ, the product of P and Q, or Q followed by P. And if you solve, this will lead us to the matrix 11, 22, 33, 60. 11, 22, 33, 60. Rejoice, are you
Please, isn't
following?
it 90?
Sir,
Yes.
It's 19, you say.
it's
Come again.
not
19.
11, it's 19.
Which one is 19?
In place
The
of
first
the
element.
Oh, yes. Thank you. So we have 1922. Please change it for me. 1922. So this is 9. We have 9 here. Let me clean it and write it properly. 19. This is 9.
Sir,
Yes.
and 33 also is supposed to be 43.
43. Okay.
And 50.
Oh,
Row 60.
yes. Yes. Please correct the matrix for me. So, what will be the final answer? 19, 22, and what?
43.
43. 50.
43, 50. 43, 50. Let me rewrite this. So, this is 4. This is 4, 43, and then 50. This is going to be 50. You take note of that, please. Good. Thank you very much. That's good. Impressive. So 19, 22, 43, 50. That is your answer to this. Then we are finding P plus Q, and P plus Q will also give us this. Confirm that. Did you all get the same thing?
Yes.
Yes.
Good. So now we need to find the image of XY. So the image of XY under P plus Q. So you see, you first need to find P plus Q before you find the image of that in your final result. We had this answer, so multiply that, and that will give us 6x plus 8y, 10x plus 12y. That is the image of xy under the transformation P plus Q. Then the next one is also there. You try it and it will give you this answer. You can confirm all these answers if they are all right. So this is how to apply matrices or solve questions involving linear transformations. We also have the second example. The next example, two linear transformations whose matrices are A and B are defined in the XY plane by that A, we have this matrix, and B, we have this matrix. Write down the matrices A and B, find the matrix BOA, find the image of the point 3, 1 under the transformation AOB. Who can tell us the matrix A and B? The matrix A and B. I'm a macho courage. Caleb. Apenyo Caleb. Joshua to me. Oh, are my student there? Kumi Monica.
There.
Okay.
So please, the matrix A would be 0 plus, 0, 1, -3, 0.
Okay.
And the matrix B would be 0, 2, 3, 2.
Okay. So we can now find the matrix BOA, then we find the image of 3, 1 under the transformation. Now, we need to wrap up. So the matrices are, so we have this, and if you solve, we have those answers there. Later, you can try these questions. There is another example there you will solve. We have example number 3 and then example number 4. You try all these examples and that will bring us to the end of our lesson for today. So we've come to the end of our lesson, and thank you for being part of us today, and we hope to meet again when we bring you uh, tutorials on combinations and permutations, combinations and permutations.